Selecting with and without replacement. In 2 and 3 step experiments where an item is selected repeatedly, the outcome of the second or third step may or may not be affected by the outcome of the previous step. This depends upon whether each selected item is returned to the set of items before the next item is selected. If it is, then this is called selecting with replacement. If it isn't, then it is called selecting without replacement. Example 7. 2 cards are drawn from a set of cards numbered 1 to 5 to form a 2-digit number. So I've only got 5 cards, and each card is with a number on it, and the numbers are from 1 to 5. A. Make a list of all possible outcomes if the cards are drawn. 1 with replacement, 2 without replacement. So let's have a look at with replacement. Now, if you take a card out and then you return a card, let's say the first card is a 1, and then you return the card, then 1 to 5 is possible for the next card. So you could have 1, 1, then you'd have 1, 2, 1, 3, 1, 4, and 1, 5. Right? If the first card is 1, and then you put the card back in, the 1 is still in there again. So you've got 5 cards to choose from. So that's why you'd have 5 outcomes, starting with 1. If the first card was a 2, and then you put it back in the bag, you've got a chance of choosing all the other numbers again from 1 to 5. Okay, that's the same with that one, and that one. And that means there's 5 times 5 is just 25 different possible outcomes. Let's have a look at without replacement. Now, without replacement, you can just see from here, there's less outcomes. The reason there's less outcomes is because if you take a card, the first card, and you don't put it back in, then there's only 4 more cards to choose from. So there's no more 1 to choose from anymore because you didn't put it back. So you can have 1 and 2, but you couldn't have 1 and 1. But you could have 1 and 2, you could have 1 and 3, 1 and 4, 1 and 5. So there's 4 outcomes starting with 1. Similarly, if you took a 2 out and you didn't put it back on the table, then really that's called without replacement, right? You didn't put it back. So then you've only got a choice of getting a 1, a 3, a 4, or a 5. You can't get the 2 because that card was the first card. And similarly with all of those, so there's 5 times 4, there's 20 different possible outcomes. I think it needs to be cleared up, however, that basically you're only choosing 2 cards and then you start again. So you choose 2 cards, start again, 2 cards, start again. So after you choose the second card, you do put both cards back on the table, obviously. Now, I've just left this up here. This is from the previous answer, A. B. If the first card is replaced before the second card is drawn, find the probability that the number formed is. So now we're talking about probability. Okay, let's use this outcome table that we got in the previous part, part A. It says with replacement. So that's what we're talking about here. It's replaced. So B is all about with replacement. It's this table here, or table of outcomes. So to get an even number, we just go through there and count up all the even numbers. All right, so it's obviously going to be that line there and that line there, and there's 10. So we put the 10 over the total number of outcomes is 25, so the answer is 2 on 5. Okay, 2, the probability of greater than 30. Well, again, you just look through there, greater than 30. It looks like this one, and that one, so that looks like 15. 15 over the total number of outcomes is 3 on 5. And then 3 divisible by 5, so it looks like that line there. There's 5 of them, so that's 5 over 25, which is 1 on 5. Okay, part C, again, I've got this from our first part A, where we did without replacement, because question C is to do without, it's not replaced, without replacement. So C, if the first card is not replaced, find the probability that number formed is even. Well, we just go through the total outcomes, and we just look for all the even ones. Now, they're kind of mixed up here a little bit. We've got 1, 2, 3, 4, 5, 6, 7, and 8. There, that one. Great. Anyway, there's 8 of them there. So I've got 8. The total number of outcomes is 20, so 8 on 20 is 2 on 5. Odd, go through and just get all the odd numbers. Now, these are read as numbers, so that would be an even number, for example, 12. 13 is an odd number. So we'll just go through. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, 12 on 20. That's 3 on 5. And less than 20. Now, less than 20 is just these 4 here. So that'd be 4 on 20, which is 1 on 5.